Welcome to our first video on pH concepts. pH was coined by a man known as Soren Sorensen. But for this aspect, I'm not going into all those details. For pH concept, we are going to focus on the calculations that comes out on pH and how we can get our answer easily. Now, there will be the second video which will feature acid, base, and salt. In that aspect, we'll start talking about theoretical aspects like acid, strong acid, weak acid, which acid is stronger between various acids, how we can identify a strongest acid in the midst of strong acid. Alright? All those ones will be in the next video. But for now, we want to focus our attention on calculation. Now, in chemistry, there is basically some formulas we use to get pH. I don't want to waste our time. I'm going straight to the point. These are the following formulas that we'll find useful when calculating pH. Number one, pH is equals to the negative logarithm of the hydrogen ion concentration measured in base 10. Please, this is base 10. You know that when we discuss pH, that term is used for acids. It is important to know that. And when we discuss pOH, this term is also used for bases. pH is used for acids, while pOH is used for bases. And when we discuss pH, what is involved is the hydrogen ion concentration. Please remember that this is a square bracket, different from this bracket, like this. So don't write it like this, but we'll write it like this. The square bracket means concentration in mole per dm cube. Concentration in moles per dm cube. So here I will also write concentration of what now? OH minus in mole per dm cube. It is important to state that for pH, according to Arrhenius theory, when an acid dissolves in water or dissociates in water, we get hydrogen ion as the only positive ion. It is also important to state that according to Arrhenius theory, that I can react this acid with water. When this acid dissolves in water, I am going to get H3O plus what now? Plus Cl minus. Meaning that, look at this now. This is hydronium ion. Hydronium ion can be used to replace H plus. And that is why I will write my second formula like this. I can write the pH of this solution as pH is equals to negative log, alright, of what? You know this square bracket of what? H3O plus concentration. Alright? Moving on. Meaning that we can use this or this to get pH, which is the same. Meaning that we can interchange H3O plus with H plus. Number three, we calculate pH using pH. Look at this formula now. I will change it to log in base 10 of what? 1 over H plus concentration. If you look at formula 3 and formula 1, you discover that I have removed the minus at the back of the log and that have changed to 1 all over in indices. Number 4, I can rewrite this also using this conversion. That means I'll have pH will be equals to log in base 10. This is also in base 10. Log in base 10 of 1 over H3O plus concentration. Alright, in other words, if the examiner asks me which of this expression shows the pH of a solution, or which expression can I use to get the pH of a solution, is either I use number 1, or I use this, or I use this, or I use this. So any of this in the option is correct expression for pH of a solution. Now, Moving on beyond this formula. This formula 5 is very, very important. It's a formula that relates pH with pOH. Because in some questions, we'll be asked, we'll be given pH and we'll be asked to find pOH. Or we'll be given pOH and we'll be asked to find pH. Also, in some questions, we will be given OH minus and asked to find pH. Or we are given pH and asked to find OH minus. Or sometimes, we can be given pOH and asked to find H plus. Or we can be given H plus and asked to find pOH. Whichever way the question comes, look at this, very, very important now. pH plus pOH is equals to what now? 14. Very, very important. pH plus pOH will give us 14. Look at this formula 6 now. From the ionic product of water. When we carry out ionic product of water, when the H plus concentration is multiplied, look at this multiplication, with the OH minus concentration, we will get what? 1.0 times 10 to the power minus 14 as our value. So class, we have 1, 2, 3, 4, 5, 6. Very, very important. But remember, all these are the same, just that I'm changing this convection, this one now to this. Because I said that these two are interchangeable. Please do well to pause the video and copy out all these formulas, because soon we'll start solving questions with these formulas. Alright? Moving on now. Can I remove this part? Moving on. It is worthy of note that some acids that have pH values also equally have pOH values. The same as bases. Bases that have OH minus values or pOH values also have pH values. And that is why we're having this formula. pH plus pOH gives us 14, while OH plus minus and OH minus gives us 1.0 times 10 to the power of 14. Moving on now, let's look at this question very quickly. Look at this question now. Calculate the pH of HCl solution having a hydrogen ion concentration of 0.0001 molar. Look at this question. This question says calculate the pH of HCl solution. More importantly, there's something I'm picking out from this question immediately. And what is that? That this question has given me my hydrogen ion concentration, and that's what is important to me. Hydrogen ion concentration. So the first thing I'm going to do for solution to this problem now, I want to solve. I can solve this direct. Why? Because the examiner said in the question, hydrogen ion concentration of this. Meaning that I've been given the hydrogen ion concentration. The next is for me to find pH. I can solve direct without minding the type of acid that is given to me. An examiner can say, what is the pH of angelic acid having a hydrogen ion concentration of so and so. In that question, we don't require to know what is angelic acid. Provided a hydrogen ion concentration has given to us, we can solve the question directly. See how I'm going to solve this question now. First case, let's use the normal method, because all these ones here are normal method of solving the problem. So I'm going to use normal method to solve this question. But before you do so, the first thing you need to do is to convert this hydrogen ion concentration that is given to you in standard form. Convert it to standard form. Looking at this now, I'm going to shift this point to this first number. So if I'm to convert this, I'm having 0.0001 molar, right? So it's going to be moving the point 1, 2, 3, 4. 4 times. And this number is lesser than 1. So I'm going to have my H plus concentration as 1.0 times 10 to the power what now? Minus 4. Because I shifted the point 4 times. So it's going to be 1.0 times 10 to the power what now? Minus 4. Solving with normal method, solving with any of this formula there, say formula 1, I'm going to have pH is equals to negative log of what now? Hydrogen ion concentration that is measured in base 10. So I'll put it now, pH will be equals to negative log of what? What is my hydrogen ion concentration? See it here, I'll put it there, 1.0 times 10 to the power minus 4. Alright, remember this is normal method of solving. So that the pH will be equals to, this minus is outside, this is how we solve. Then, this is log 1 in base 10. Remember this is base 10. So log 1 base 10, log 1 base 10. In logarithm, multiplication will change to addition. Plus, this minus 4 comes down, minus 4. Log of 10 in base 10. Log 10 in base 10. This is how we analyze this. So I'll finish up the solving there. Alright? This is what I'm having here from here. The minus is still outside, so pH will be equals to minus outside. What do I have here? This is log 1 in base 10, alright, plus minus 4 log 10 in base 10. This is what I have. Alright, so analyzing this now, we have pH will be equals to, minus is outside, it remains outside, log 1 base 10, 0, plus minus 4 times log 10 base 10 is 1. Minus 4 times 1, minus 4. That is how I resolve that. So you see this now. So pH will become now negative 0 plus times minus minus 4. When you open the bracket, of course, you know that your pH will be equals to what now? 4. So this is one way of solving it with the normal method. Normal method. Normal method. Alright? Now, are there shortcuts in these pH calculations? Yes, there are plenty shortcuts. I will release some of them here now. So let me list some few shortcuts that are very important. So I will say shortcuts. For shortcuts, there are easy ways of solving this. One is, whenever we have H plus concentration as A times 10 to the power minus n, then pH will be equal to what now? N minus log A. This is an alternative method of getting pH. So this is an alternative method of getting the answer. So let's see how we can use this alternative method to get answer to this same question. What was our hydrogen ion concentration? This is it here. So I'm going to write it out here. H plus conc is equal to what? 1.0 times 10 to the power minus 4. Is that also? Yes. Alternative method, what do we say? So compare these two things now. Compare these two things now. What is my A? Of course, my A is 1.0. Compare these two. This is minus n and this is minus 4. What is my n now? My n is 4, not minus 4, because what I'm having is minus n and then minus 4. So what corresponds to n? That is 4. So my n is 4. So I'll finish up this calculation here. Permit me to remove this now. Alright. I'll finish up the calculation here. Now we are having, I said we can use pH is equals to n minus what now? Log A. And our A is what? 1.0. What is our n? 4. So I can get my pH. pH becomes, what is N? N is 4 minus what is log? What is A? A is 1.0. So if you do this successfully with your calculator, pH will be equal to what now? 4 minus log 1. Log 1 is 0. 4 minus 0, what do we have? We have 4. So 4 is our answer. The same answer with the normal method. So this is shortcut 1. One way of getting the pH faster. The alternative method is faster than the normal method. Alright? So the other shortcuts I want to give out now are very worthy of note. You need to understand this formula. Very, very important. Remember that what I've been solving since is pH. How to get pH when it is not known. When the examiner says find pH, we use the normal method or we use this alternative method. But what if reverse is the case? That they now give us pH and ask us to find H plus. Examiner giving you pH, asking you to get H plus. Or examiner giving you pOH, ask you to get OH minus. How do we do this? Shortcut to get this. Shortcut. Now, OH minus concentration is gotten by 10 raised to the power minus pOH. In the other hand, H plus concentration is always gotten by 10 raised to the power minus pH. So that when the examiner gives us pOH or pH and asks us to get any of these two, if we have the OH minus, 10 raised to the power minus pOH will give us OH minus when we have the pOH. So this relationship is very, very important. It is formula by way of shortcuts that give us our answer faster. Do well to pause the video and take down these two formulas before we solve another question there. Shortcut 3, let me put it here. This is for those writing objective question that doesn't even want to solve at all. You don't want to even solve, let alone using calculator. You don't want to solve anything at all. You don't want to solve the question at all. What do you need? You just want to get your answer even without solving. There is a way we go about it. Look at this. If hydrogen ion concentration is given as A times 10 to the power minus N, class, let's take that question we solved initially. Question 1 that we solved, H plus is this. We had 1.0 times 10 to the power minus 4. Alright? There is a way you can estimate the pH without even solving at all. Knowing your answer before you even solve. How do we go about that? When I look at what I'm given as H plus, I have 1.0 times 10 to the power minus 4. Is that not so? Yes. Now, look at this condition. When A, this A you are seeing here, when this A is equals to 1.00, meaning that when it is exactly 1, when this A here is exactly 1, you don't need to solve. Then, how do you get your pH? N is equals to pH. What does it mean? Once you give me hydrogen ion concentration and I change it to standard form like this, and I find out that the number that is here, which corresponds to my A, is exactly 1, then whichever number that is here is my pH. That's what I wrote here. N is my pH. Look at the first question we solved in the case of HCl. What is the value of A? 1.0. What is my pH? N, which is what now? 4. So for question with this now, what is my pH? Since A is 1, my pH is what now? 4. Because my pH is N. Now what is N? 4. pH. Alright? But the question many students are asking, what if this A is not equal to 1? What if this A is not equal to 1? Look at that condition here. I'm going to put it here. If the A is not equal to 1, let's say it is something like 2.00 and above, but it is not above 10, meaning that when, I'm going to put that condition here now, when A is not equal to 1, but it is greater than 1, but less than 10. What do we do? This condition, whenever we have it like this, let's say for example, we have this. We have H plus concentration is, let's say we have something like this, 2.0 times 10 to the power minus 5. This is our H plus concentration in a question, assuming now. In this case, when the A is not equal to 1, our pH is between N minus 1. Of course, what is N in this case? When you compare this with H plus A times 10 to the power minus N, compare this with this. Your A is not equal to 1. What will be your pH? It is between N minus 1. And what is N? N is what? 5. So what will be my answer? 5 minus 1. So the answer to this question will be what now? The answer to this question will be 4 point something something. 4 point something something. So this is your answer. This is a way of knowing your answer even before you solve. So this is very, very, very important for those that are writing MCQ questions, that's multiple choice question, objective. All right? But for those writing theory, you may want to use the normal method. But if you still use the alternative method that I used earlier, which is pH is what? N minus log A, you will still be given your mark in theory question when you use this alternative method. But for those that are writing objective questions that doesn't require to show their work, you can use this shortcut to know what your answer will be before solving. Then now, let us solve this question now with the normal method to see if we have 4 point something as our answer, to prove that the shortcut is very, very correct. Now, look at how we are going to do it. We can even solve it faster with this alternative method, of course. But let's go by the way of normal method. By way of normal method, what is my H plus concentration now? See it here. It is 2.0 times 10 to the power minus 5. How do I solve by normal method? Of course, what's pH? pH is equals to negative log of H plus concentration measured in distance. So what will it be now? pH will be equals to negative log of what? What's my H plus? 2.0 times 10 to the power minus 5. Solving this now, what will be the pH? pH will be, the minus is always outside, alright? And remember this is in base 10. So minus is outside, open bracket, log of 2 in base 10, log 2 base 10, times changes to plus in logarithm, so this becomes plus. The minus 5 will come down, minus 5, log what? Log 10 in base 10. If we resolve this successfully, pH will be equals to minus log 2 in base 10, 0.3010. Alright, that's the value. You know that there are some logarithms you are supposed to know, like log 2. Of course, log 4 will now be log 2 times 2. Of course. In our next video, I will show how you do that. Now, this is minus 5 times 1, because log 10 base 10 is now 1. Minus 5 times that 1. This is how I resolve this. So if you do this now, pH will be equals to, minus is outside, 0.3010. Then this is what now? Minus 5. If you do this successfully, pH will be equals to, of course, when you resolve this with your calculator, your answer will be what now? Final answer will be 4 point something, which makes it correct what we did here with this shortcut. So with this alternative method, you get your answer even without solving. Alright? You get your answer even without solving. Alright? So you can complete this with your calculator. When you punch your calculator, you get 4 point something. Alright? So we'll go on now to show some examples. We'll solve some questions now. Remember this. Remember this. Sometimes the examiner will give you a question that does not contain the hydrogen ion concentration. In that case, what you need to do is to find the hydrogen ion concentration, then solve with any of these our method. Alright, let's look at this question very quickly. A sample of orange juice is found to have a pH of 3.80, which is the concentration of the hydroxide ion in the juice. Alright, solution to this problem, solution. Now this question is asking us for hydroxide ion concentration, meaning that we are asked to find OH minus. We don't know this. This is what we're looking for. But what we are given in the question is what? pH. We are given pH to be what now? 3.80. Now remember what I said earlier, that pH works for acid and pOH works for what now? Base. And when we're talking about pH, what we use is H plus concentration. And when we talk about base, we use OH minus concentration. So you look at this, very, very important. So look at what the examiner did here. They did not give us pOH and they now ask us to find OH. What they gave us is pH and they say we should find OH minus. There are two ways in which we can solve this question. One way of solving this question is by, first of all, getting pOH. Then when we get pOH, we use the pOH to get the OH minus. Recall that pH plus pOH will give us 14. What is the pH in the question? 3.80 plus pOH will give us what now? 14. So that, what will be the pOH? pOH will be equal to what now? 14 minus what? 3.80. If we do this, pOH will become what now? 10.20. So I have gotten pOH. I can now proceed to use this to get my answer. So what will it be now? I'll just quickly say that since I have my pOH, I can use this to get my OH minus. So getting my answer now, so I'll do it here. Using this formula now, so what will be the OH minus? OH minus will be what now? 10 is the power what now? Minus pOH. So what is pOH? Minus 10.20. If you point this in your calculator, of course, you are going to get this as answer, which is our answer to this question. So how did I solve this now? Of course, if you point your calculator, 10 is the power minus 10.20, this, of course, will be your answer. So this is our answer. All right? This is our answer. Now, I said this is one way of solving this question. All right? Get the pOH from the pH given. Then you can use that to get OH minus. Of course, this is the way we do that. But had it been used this formula, what you would have gotten is option A, which many people picked in this exam, which is very wrong. This A is for H plus concentration, not OH minus. But remember, the examiner said, what is the concentration of the hydroxide ion? So this is one way of getting the answer. All right. We can also use we can actually use pH to find H plus. Then use the H plus to find the OH minus. That's alternative way of doing this. So if I must do that now, method 2 of solving this question. Method 2. If I use pH, I was given pH of what? pH of 3.80, right? So I can say, since pH is negative logarithm of the hydrogen ion concentration, I can get my H plus. And what's H plus? H plus will be equals to 10 raised to the power minus, minus pH. So that will do that. H plus, what will it be? 10 raised to the power minus 3.80. Of course, I said you are going to have this value. Let's check that once again to confirm that. So if you do that, 10 to the power of minus 3.80. I will get, of course, 1.6. That's it. So H plus conc will be equals to 1.6 times 10 to the power minus 4. So this is all we will get. We have this now. We can use it to get OH minus. How do we do that? Recall that I can put that here now. Please, you can pause the video and take this information. All right. Let's see what I will get. Recall that OH minus concentration when multiplied by H plus concentration will give us 1.0 times 10 to the power what? Minus what now? 14. Of course, do I have H plus now? Yes, this is it here. So OH minus concentration into I have this now. So this is this 1.6 times 10 to the power minus 4. So what will I get now? 1.0 times 10 to the power minus 14. Right? So what will be the OH minus now? OH minus conc will be equals to what now? Of course, the collected items now, 1.0 times 10 to the power minus 14 divided by 1.6 times 10 to the power minus 4. When we do this successfully, we will get this as answer. So you can check that, All right. 1.0 times 10 to the power of minus 14, all right, divided by 1.6 times 10 to the power of minus 4. What do we get? Of course, that's our answer. So this is our answer. We will get 6.25 times 10 to the power minus 11. Of course, you know that this with this is same. So please, this is how to go about it. This type of question. This is how to go about it. All right. So our correct option here is B. 6.3 times 10 to the power minus 11. So if you are given pH and you are asked to find OH minus, you can use the first method I used in solving it. By using pH plus pOH equals to 14, you get pOH. Then from there you solve. It is possible the examiner can give you pOH and now ask you to find hydrogen ion concentration. This method will still go for it. Thanks for watching. In our next video, we'll solve plenty questions on this. Remember that our next video will center on acid, base, and salt. All right. Remember to subscribe. Remember to like. Remember to share, and also remember to comment. And also remember to keep comments respectful. See you in our next video, which will feature acid, base, and salt. Then calculations on pH. We'll see how to solve many questions. We'll just be solving questions from next video. See you in our next video.